moving on. First three terms of geometric sequence are blah blah. Find the value of r. So it would be r is 1.6 divided by 0.64, or 4 divided by 1.6. 2.5. And find the value of S6. So looking at so it's a geometric sequence. So we're looking at the sum. So because the value of r is positive, we're going to use this version, and we know that s is 6. So, sorry, n is 6, so we're finding s6. So that's u1, which is 0.64, r, which is 2.5 to the power 6, minus 1 over 2.5 subtract 1. And let me just stick that in the calculator. So 0.64 bracket 2.5 to the power 6. Subtract 1 over 2.5 subtract 1. 103.74 to 366. Obviously, that would be 104. Find the value find the least value of n such that the sum is greater than 75,000. So we would have this expression for the sum. So 0.64, 2.5 to the n minus 1 over 2.5 take away 1 has to be greater than 75,000. Okay, so we've got 0.64. This is 1.5, so 75,000 multiplied by 1.5. Our unknown is in our power, so we're going to be taking logs. So we've got 2.5 to the n minus 1 is greater than 75,000 times 1.5 over 0.64. 2.5 to the n is greater than 75,000 times 1.5 over 0.64 plus 1. So let's find out what that number is. So 75,000 multiplied by 1.5 over 0.64 plus 1. 175,782. 82.25. Okay, so if we are taking logs now of both sides, it doesn't matter if it's log or LON. So n to be greater than log of 175,782.25 over log 2.5. Remembering that n comes in front of the power, so we're obviously then going to divide by that. So we've got log of that value divided by log of 2.5. I'm going to do log of the answer. divided by log 2.5. 13.1, n has to be greater than 13.1, so which means n has to be 14. Okay, velocity, blah, blah. Following diagram shows the velocity. Find the value of t when the particle is at rest. It's at rest where the velocity is 0. So, we are going to draw this function. Right, okay, sorry for the interruption. So I've entered the equation into the calculator. And I'm going to put the, I know numbers. Okay, so we're going to graph it. And we're going to find where it's 0. So second calc. Second calc. And we're going to find where it's 0. So it's at 4.28. Find the value of t when the acceleration of the particle is 0. So we know acceleration and velocity are linked through kinematics. So we would differentiate the expression and equate it to 0. So okay, so we need to find the, sorry, I got sidetracked. We need to find the value of t when the acceleration is 0. And so we know the connection between velocity and acceleration is that their derivative is each other. And so the derivative of this function here would give you the acceleration. And that's going to be 0 when the derivative, when this actual function here is at a minimum. Okay, in other words, down here somewhere. So what we need to do is use our calculator. We've already got that in there, and we're going to calculate when that is at its minimum. So left bound, right bound. So it's a minimum at 1.19.